We use A cross B equals to 0 when we use A dot B equals to 0. One is perpendicular, one is parallel. Which one is which? This one? Perpendicular. This one? Or parallel. So if they ask you prove that A and B are perpendicular, they show that A dot B equals to 0. Right? May I ask why is it equals to 0? Because the formula is A dot B equals to modulus A modulus B cos 90, and cos 90 is equals to 0, so that's at the right. So that's why the right side collapse equals 0. Okay? This one here, why is it equals to 0? Well, there are many ways to look at it. You can say sine is theta doesn't exist, stuff like that. But I like to imagine it something like this. You need to understand, when you A cross B, normally, in normal cases, you get a new vector. Okay, this is a scalar, this is a vector. Scalar, this is a vector. So, when I give you, let's say this is vector A, let's say this is vector B, if they cross, if they ever intersect, they cross, you have a new vectors which is a normal vector. A new vector will come up. Regardless of the angle over here I talked about yesterday, regardless of the angle, I will still have a new normal vector. But it will only happen when it cross. Now, if they are parallel, will they ever cross each other? They will intersect each other. So there's no new normal vectors. I like to imagine it like that. So there's no normal vectors, so that's why it's equals to 0. Okay? That's one way to show it's parallel. There's another way which is alternative. How do you show it? Well, I gave you an easy example yesterday. A1, 2, 3, B2, 4, 6. And C, let's say negative 1, negative 2, negative 3. Are they the same? They are not the same, but they are parallel. Why they are parallel? Because this one to this one is a scale. I times by 2. Scalar or times 2. This one to this one, yes? Scalar of negative 1. Okay, so let's say if you are given something like this, if over here you don't know, if they put here lambda, so what will it be? Simply lambda is negative 3. You can give me one guess, what is it? Alright? Okay, so that's the alternative way of solving. Okay, right, that's all. Any question? Okay, thank you. Please comment, share, like, and subscribe. Okay, alright. So, sekadar contoh again. Just for example, if you want to show this is orthogonal or perpendicular, other name just now I just mentioned is orthogonal. We use A dot B. So simply A dot B will be 2, 5, negative 9. Let's say this is your example. B is negative 5, 11, 5. Dot it up. This is a scalar. So negative 10 plus 25 minus 45. So this one, if you total up, equals to 0. Once you reach 0, you should write down A and B are perpendicular. Okay, so that's the example if you want to show the perpendicular in calculation. The other way is for this one, if you want to show the parallel, 1, 2, 3, and 2, 4, 6. Well, A cross B will be, in terms of I, J, and K, 1, 2, 3, 2, 4, 6. So close this one, 2 times 6. 12 minus 3 times 4, 12 minus 12. I plus, close this one, 6 minus 6, 6 minus 6, J, and finally, close this one, 4 minus 4, okay, so this one you get 0, 0, 0, 0. So once you reach 0, you should write down A, B are parallel. Okay, that's how we show in terms of calculation. Right, thank you.